In this module, we'll work through examples of queries that use joins to select data from more than one table in the database. First of all, I'm going to show you a cross join and tell you there's really not much real-life use for a cross join, but you should be familiar with what it is. I've written SQL for over 5 years and I've never used a cross join for anything. But here's a cross join so you can see an example. Here we're selecting the name, gender, and gender description from the person table cross-joined with the gender table. And what it gets us is what's called the Cartesian product of these two tables, which is basically saying it's going to get all possible combinations of the values from both tables. So you can see that for each person in the person table, this query is selecting 3 rows, one for every gender in the gender table: female, male, and unknown. There are 90 rows in the person table and 3 rows in the gender table, so this query returns 90 times 3 rows, or 270 rows. Like I said, there's really not much practical use for this, but you should be familiar with it just in case. If it helps, when we do inner and outer joins, we're always going to specify a condition with the join. So for example, we might inner join person to gender, where person gender equals gender ID, but in the cross join there's no condition, we're just joining everything. Our first example will involve a very simple join, so write a query to solve this problem and then come back and I'll walk you through it. Problem 1. Write a query to select person last name, first name, and gender description from the tables person and gender. Hint, it may help to first do a select star from person and a select star from gender to give you a better idea of what's in each table. You can also reference a database diagram if that helps. So here's a solution. We're selecting the last name, first name, and person gender, which is going to get us the gender code stored in the person table, and the gender description, which is stored in the gender table. And to do a join, in our from clause, we add the word join, the name of the table we want to join to, then the word on, and we specify which columns are equal to each other. In this case, the person gender field in the person table is going to match up with the gender ID in the gender table. If you need to, you can look at the database diagram and you'll see that gender ID is the primary key in the gender table, and so person gender in the person table is the foreign key. So since we want the gender description, we join the tables by these two fields, person gender and gender ID. Problem 2. Write a query that selects the staff ID, last and first name of each staff member in the database, and the site description for the site where each staff member works using joins. Use aliases or correlation names for each join table. Hint, you may need to join more than 2 tables to achieve this. So here's a solution. For this one, we needed to join the staff table to the site table, which stores the site codes and the site descriptions. We also needed to join to person to get the person last and first name. So we're selecting the ID from the staff table, last name and first name from the person table, and the site description from the site table. And this time we've got 2 joins. We have to join the person table to the staff table, so we get the staff, and we're getting records where the person ID and the staff ID are equal. If a person isn't a staff member, this query won't select that person since they don't have a record with their ID in the staff table. We also have to join up to the site table so we can get the site description for each staff member. So we're joining staff to site, where the site ID in the site table is equal to the staff employment site in the staff table. And also notice that as the problem requested, I used aliases for the table. So after each table name, I alias the table using as and then my alias name. For example, person as P. And then in each place where in my query where I refer to a field in the person table, I call it p.field. So I select p.person last name and p.person last name. Problem 2b. Modify the query so it also selects the staff gender description for each staff member. So to do this, we now have to join up to the gender table. So now we have 3 joins. And as you can see, I've aliased the gender table as G. And I'm joining gender to person, where the gender ID from the gender table and the person gender from the person table are equal. And then I just need to add g.gender description to the list of columns that I'm selecting in this query. Problem 2c. Write the query from 2b so that it uses the older or implicit join syntax. So there's actually a way to join tables without using that join keyword. And this is not the way we're usually going to write queries in this course, but you should be familiar with it just in case you come across queries that are written this way. And this is sometimes called the implicit join syntax, whereas the other syntax, the one that uses the join keyword, is called the explicit syntax. So in this example, we've rewritten that last query using the implicit syntax. Here, in the from clause, we just list which tables we're selecting from. And then we actually define our joins in the where clause by specifying which fields are equal to one another. Problem 3. Write a query that selects patient ID, last name, first name, and description of the patient's preferred site, but only selects the patients who prefer sites Beechview North and Beechview South. So there are a couple different ways you could have approached this problem. Here's a first way I'll show you, which is that we actually defined our condition or requirement that we're only going to select the Beechview patients as part of the join itself. So we actually have a statement inside the second join that says we're going to join the patient table to the site table, where the patient preferred site from the patient table is equal to the site ID from the site table, and the site description from the site table is like Beechview. So that name of the description begins with the word Beechview. Here's another way you can write this. Instead of defining your Beechview condition as part of the join, you just define it as part of the where clause. We do the join, and then we have any further conditions in the where clause. Either of these two ways works fine, and you'll get the same results. And in the second example, I've added alias names as well.